at the end. So thank you for attending today's RDA webinar on FAIR principles. I am Katrin Beck from the RDA Europe webinar team. Now let me present you our speaker. Dr. Michel Dumontier is a distinguished professor of data science at Maastricht University. His research focuses on the development of computational methods for scalable integration and reproducible analysis of FAIR, findable, accessible, interoperable, and reusable data. His group combines semantic web technologies with effective indexing, machine learning and network analysis for drug discovery and personalized medicine. Previously at Stanford University, Dr. Dumontier now leads a new interfaculty institute for data science at Maastricht University with a focus on accelerating scientific discovery, improving health and well-being, and strengthening communities. He is a principal investigator for the NCATS Biomedical Data Translator, a co-investigator for the NIH Data Commons, and a co-investigator for the NIH BD2K Center for Expanded Data Annotation and Retrieval, CDAR. He is a founding member of the FAIR initiative, a member of the Dutch Tech Center for Life Sciences, and is the scientific director for Bio2RDF, an open source project to generate linked data for the life sciences. He is the editor-in-chief for the iOS press journal Data Science and an associate editor for the iOS press journal Semantic Web. So let's start our webinar.
Great, thank you very much, Catherine. Thanks for extending to me the invitation to present to the group, and thank you all for joining today. I look forward to taking some of your questions after I go through the webinar. So today's talk, I wanted to tell you a little bit again about the context behind FAIR, what we intend, and the work that we're doing now to develop metrics to assess fairness and the ecosystem that we're building. And I think it's an exciting story that's unfolding. So let me start with a little bit of motivation here. So somebody wants webcam. Okay, I can webcam this. Yeah, happy? Okay. An increasing number of discoveries are being made with other people's data. I think that bodes really well for us that we can reuse what other people have been creating for many, many years in new scientific investigations and find really interesting things. So let me show you one example of this. Pravesh Khatri, who is a colleague of mine at Stanford University, had this idea about trying to identify genes that would be responsible for the rejection of organ transplants. And what he did was he used a database, an online database called GEO, which stores information about gene expression data from various tissues and different organs and so on. And what he did was, instead of just focusing on one tissue like heart or lung or kidney, is he built a meta-analytical framework to combine gene expression data from all of these different kinds of tissues in order to find a common signature, gene signature that may be responsible for rejection. And so in doing so, you can see which genes are up and down regulated in each tissue from each experiment. And then the idea in the meta-analytical framework is by combining these data, we have a better sense of exactly the magnitude of that gene expression change from those transplants that are successful and those that are not successful. And so this improves the quality of the science being done by giving us increased confidence about any one result. But what the work really did was identify that there a common rejection module in which the genes are correlated with the extent of graft injury and could be used to predict future injury to a graft. And then from this signature, they could also attempt to identify drugs that could modulate the signature, basically try to counter the gene expression that was observed. And they found drugs that were treated drugs that could be used to treat mice with these organ transplant could extend the graft survival. So a really nice example of using other people's data to do a modern scientific experiment and to validate that experiment and really increase our understanding. Now, that's a great story, but when you talk to Pravesh, he says, you know, the frustrating thing about that was that we had to spend enormous amounts of time sifting through the geodata sets and really curating the information we needed to decide whether we wanted to include them in our analyses, and sometimes also the conditions for exclusion, which just weren't available in the metadata that was being provided. And so it took them a lot of effort to find the right data sets, to put them together, and then to finally use them in their analysis. And what that begs is that we really have to rethink the role of data and publishing data in the context of certainly academic publishing. Right now, the way it works is that we will collect our data, we will do some kind of analysis, we'll publish our result, and the data is a secondhand sort of notion, right? So, oh yeah, here's the supplementary material. There it is in a PDF file, right? Tables and all kinds of things. And we don't really treat it with the serious nature that it should be treated, because this data is really the foundation for reproducing other people's work, for using it to validate your own experiments, and to generate new hypotheses. So this is, I think, the future for certainly the scientific enterprise, is to treat data as a first-class object, something that really has merit that we need to treat carefully, and to release it in such a way that other people can use it in ways that we hadn't anticipated. So we have to figure out how to reduce the barrier to automatically find and reuse that content if we're ever going to realize the full potential of the content we create. And I think to achieve this objective, we really have to build a new social and technological infrastructure for the discovery and assessment of digital resources. And that really is what brings us to the idea of FAIR. So the idea of FAIR is to improve discovery and reuse of digital resources. And particularly when we first started thinking about this, it was amongst the academic community, but we also, were interacting with people from the funding agencies, from our industry partners, from publishers, really having a rounded conversation about what we're trying to achieve. And the principles for, are to make digital research projects findable, accessible, interoperable, and reusable. And initially that discussion started with data sets, but we can imagine that it could be applied to all digital resources, whether they're images, software, web services, repositories, scholarly publications, and so on. Anything really that you can put on the web, we should be able to improve their discoverability, how we access them, how they interoperate, and how we can reuse them. So I'm really proud to have been part of a very large group of people. Many of them are actually even on this call, and I call out to everybody who's contributed to this initial idea of the FAIR guiding principles. And we've seen a great uptake, which is super exciting in this paper, and in particular impactful in the sense that we see endorsement through the G20, and discussed and sort of adopted within the European Open Science Cloud, and within the H2020 and the NIH programs as well. So this has had, the excitement around FAIR, I think to a large extent embody what we had all been thinking. We were able to synthesize, I think, a set of principles that resonates, and also a mission that resonates with lots of people, and we're seeing great uptake. Now, of course, the challenge is that while these principles that we have here are sort of individually telling you a little bit about what does it take to be findable or accessible, interoperable, and reusable, the question of how to what extent, what work do you have to do to make this happen is still an open question, and one that I'll address in this talk a little bit. So the principles, really talk about coming up with using globally unique, resolvable, and persistent identifiers to use machine-readable descriptions to support structured search, that access and security protocols are clearly defined so that you can get data that may not be open, but there needs to be a process in which you obtain that information, that the metadata for these resources will always be available. It's much easier to produce, and can be held in perpetuity, so we can refer to it in the future, that we use formats that are really extensible to lots of different kinds of data and metadata, that vocabularies themselves have had some work to make them abide by these principles, that we link to other resources, and then we also provide the necessary licensing statements around those resources that we release, so there's clarity in reuse, that there's detailed provenance so we understand how they were produced, and that they use community standards to enable interoperability or use in existing platforms, and so on. Now, just as an example, that we can also eat our own dog food. So we were challenged one time to create a description of the FAIR principles themselves using, the semantic web technologies, and we've done that. So here's a snippet of it where we publish the FAIR principles as a nano publication. So we have machine readable statements. It uses ontologies. You can query these principles here, and you can link to them, you can refer to them, and so on. So it's possible for even the principles themselves to be published as FAIR. So our hypothesis is that improving the fairness, that going through the motions of trying to address each of those sub-principles are going to increase the fairness of the digital resource, and that will increase the quality and the potential for reuse. And it's important here that what we're talking about is potential for reuse. We recognize that some data sets and some digital resources will never be very popular. They are valuable in their own right for particular questions or for particular kinds of analyses, but they may not have the same popularity as other resources. And that shouldn't be counted against them, because at the end of the day, when somebody wants to use your resource, they should be able to with minimal effort. And that's really the aim of the FAIR principles here. So what do I mean by fairness? Fairness reflects the extent to which a digital resource addresses the FAIR principles as per the expectations defined by a community. And so that kind of leaves us open, right? What do you expect as a community from the other people that produce digital resources that you intend to reuse? What are your expectations, and how are those being communicated, and how are we holding the standard up and assessing people? And this is really the big challenge. And so what we imagine is that communities, so if we can do this kind of assessment of fairness, then communities who have particular digital resources, so for instance, this repository is the DANS repository, they have a number of different kinds of data sets, they imagine that they will be able to do some kind of assessment and give you some kind of visual indicator about the degree to which the people who created those resources have made them fair, right? Have put some work into it to address each of the principles. And so you can see a visual illustration in this, which is just a mock-up, right? Other communities are also thinking about, like, how are they going to visually communicate the fairness of their resources. So to measure fairness, we imagine that we would have to have some metrics, some measures or standards of measurement. And so these metrics should provide a clear definition of what is being measured and why one wants to measure it, right? So what are we asking for, and why is that important? Because you can imagine that you could generate hundreds, if not thousands, of different kinds of measurements, but are they really useful, and what purpose are they going to be used in? And I think those are important questions to address. They must also describe the process by which you and any other person could obtain a valid result so that it can be reproduced by others. And we need to specify what a valid result is. So these are the basic aspects of what a metric should do, and maybe how we should operationalize it. So I think good qualities of a good metric include that they are clear, anyone can understand the purpose of the metric, they are realistic, in which compliance should not be unduly complicated, but it can certainly be more sophisticated than we currently have, obviously, because we haven't met fairness in all of its glorious diversity as we might expect. And so more effort may be required than we currently are putting into them. But it should be realistic nonetheless, that there's a pathway by which we can achieve those objectives. They should be discriminating, so the measure can distinguish between those that do meet and those that don't meet the objective. They should be measurable, right? We should be able to make some kind of objective and quantitative, machine interpretable, scalable and reproducible experiment and return results. And I think the metrics should also be universal. They should be applicable to all digital resources, whether they're data sets or repositories and whatnot. And then these are going to be the most valuable kinds of metrics. Now, so a small group of us tackled the issue of designing metrics, at least to get started with, as a starting point for the community to have a discussion about what are good metrics, and are these really going to be useful for me and the community. And so we've come up with 14 universal metrics. We published this now in a bioRxiv paper, and they cover each of the FAIR sub-principles. The metrics really demand evidence that you or the resource creators have addressed some of the principles. This includes providing web accessible documents with machine readable metadata that detail how you are managing the identifier schemes, how you're going to maintain that in the future, what your commitment is to the metadata and providing that in the longest term possible, and also clarify any additional authorization or authentication procedures required to access that content. They must ensure the public registration of their identifier schemes, to also provide a description of the security around access procedures, to use knowledge representation languages that are, again, universal and can be reasoned about, that licensing is provided, and that there is detailed provenance. Now here, in the first part, we really talked about you have to provide this, but here we're asking, when you specify your identifiers, your access protocols, your knowledge representation language, your license and your provenance, they need to have been recorded elsewhere. Somebody else has to have a list of all the possible choices, and yours is one of them. And that sort of indicates that there's community acceptance, and certainly the kinds of information about those standards need to be provided as the expectations of those communities when you record them. In the last bit, you must also provide evidence of the ability to find a digital resource in a search result, in linking, that there is links to other resources, and that these linked resources are fair themselves. And finally, that you are meeting community standards. And again, things like community standards need to be recorded in some place. So really the focus on this metrics work is that you have to provide evidence or proof that you are following the FAIR principles. And so that primarily reduces down to giving URLs to each of these different items that we're asking you about. Right, so here's an example of one for the identifier is FMR1.3, and this addresses the part of the meets community standards. And so here, what we are expecting is that for a community that develops some kind of standard, let's say it's a data format or some kind of standard like that, then they must also have a process by which they can examine say the metadata document or the digital resource, whichever one. They should be able to parse that and be able to indicate that you have met the criteria expected by that community. So the criteria have to be formalized, right? They have to be computable. It has to be applicable. And finally, you need to be able to obtain a certificate that you have met those conditions. And that needs to be issued by such a community. So the days of sort of self-reporting and saying, you know, I believe, or in the spirit of the standard, I have met the expectations and I'm reporting, yes, I have done so, kind of have to end. We really need to operationalize this, make it a computational platform, and for others to do the validation on, based on the input that you provide. So there are lots of models for this, of course, and I think it's something that we have to bring to, certainly to the scientific community. Okay, so an example, right, so is that previously I and many others were involved in the development of a standard for describing data sets called this HCLS community profile, which we developed under the World Wide Web Consortium in the Healthcare and Semantic Web for Healthcare and Life Sciences Interest Group. And in there, we identified different kinds of metadata elements that we would expect and how to encode those metadata elements. So that's a nice document, right? It's a standard. It's one that you can refer to. And what we've done is we've registered that standard in fairsharing.org. And Fairsharing has a collection of different standards, databases, and policies, and really captures additional metadata that we would expect in order to understand what is this thing and who's in charge and how do I get contact with them, and so on and so forth. So this is the step that we have had to do, for instance, to be more fair with respect to the standard. To have a fair standard is that it's registered in a repository like this one. Okay. Now, another standard that we had been developing is called the Smart API standard. And the idea here is that we have a standard for describing application programming interfaces or APIs, and primarily those that are on the web, so web APIs. And what we really want to get at with this API is that we first have good metadata about your API. We understand what it is, and we know which operations are possible and what parameters can be used. At the same time, what is the kind of result that you will produce? And this is in the context of being able to build a repository of such APIs, and be able to mix and match and be able to create pathways between what I have right now and where I want to get to. So it's a bit about generating workflows and all kinds of automation in the scientific field. Now, one part is that we also want to see, we want to build this out in order to link what are data APIs, so repositories that can provide you with information about individual records, individual objects. So for instance, in Bio3DF, this is one of our linked data projects. We have lots of interesting information in the biology domain, and they are all linked together. But at the same time, you have these software APIs like mygene.info, myvariant.info that collect information and also have the potential to link it up. That the result of an API could push you back into the linked data network, and the linked data network could push you back into the APIs that could generate new information. So we want to see this seamless interplay between these two, and part of that is about adopting common standards, generating globally unique identifiers, and so on and so forth. So it's really embodying the FAIR principles, but for APIs. And so when I was preparing this talk, I sort of said, oh yeah, right, is Smart API in FAIR sharing? And it turned out it wasn't. So yesterday I made my submission, and you can see right now it's awaiting approval by the biosharing team. So hopefully we can get an answer back. But again, this is the process that we, as people who devise community standards, we need to go through in order for to become as fair as we can be. Okay. So at the same time, our group had been, in particular Mark Wilkinson, who's also on the call, had been thinking about how do we create an infrastructure to support the execution of these metrics in some kind of semi-automated way. And so the idea is as follows, right? So you want to know how fair is this digital resource? And then you have to question, well, by whose standard, right? So by whose standards are we going to evaluate? And we expect that we will have a registry of community-specific fairness tests, things that we outlined in our universal metrics, but then potentially other kinds of more specific resource-specific metrics would be retrievable. And then what we want to do is ask, okay, here's the information that's required in order to meet these community standards, to meet the metrics that have set out. We want to compute that on the information that you provide to validate the inputs that you have provided us and make sure that other people can also confirm the work that has been done. And to generate an output, which is an assessment that can be stored and then retrieved in a subsequent encounter, for instance, in some kind of repository, as we saw with DANS, or other kind of system. So this is the main idea, is that these metrics now that make a computation, that do an assessment, would themselves also be fair. They will be services that would be described with a Smart API description. And from this, we can automatically invoke that metric with the appropriate information. And then we can store that information later on. So these metrics, just to give you a sense, are available for public discussion in our FAIR Metrics GitHub. And you can make suggestions and comments through the issue system. They're represented as nano publications, in LaTeX, as PDF documents. They're free to use for any purpose. And we will be doing version releases through Zenoda as the metrics evolve, with the first release already available for download. Now, the other big development is that where we have obtained some very nice funding from the NIH through their Data Commons pilot phase. And the idea is to further explore, as one part of that big effort, the development of FAIR metrics, and to create infrastructure and systems that really support us being able to do these assessments, to build these metrics out, to do the assessments, and to start viewing the results of these assessments. The Commons is focusing on a few different data sets. So there's the TopMed one, GTEx, and some of the model organisms. These will be the substrate for the development of our tools and services. And we will combine the assessment of those data sets with, again, some of the resources I've mentioned, like FAIR sharing, ontologies that you might find in the OVO Foundry, and other kinds of common elements, metadata elements, for instance, and common data elements. And so the idea for us is to do an assessment of the landscape, to engage with the stakeholder communities, especially, for instance, RDA, the NIH communities, and many others, to gather requirements about what are the expectations for metrics and for the working of the system, and to start developing these community-based metrics in addition to the universal set of metrics that we think can apply to all resources. To build these scoring engines, so in that you can discover the metrics that are available, you can invoke them, you can score the resources, and you can store these scores for use in some downstream application, whether, for instance, in fair sharing, might query some kind of repository and say, what is the assessment available? What assessments are available for this resource, and be able to show it. In the bigger picture, you may have heard of this development. So there's the establishment of something called GoFair. It's called Global Open Fair. And the idea is to build an international consortium to start to establish the higher order that we need to figure out who are to help build this infrastructure, to help provide training, and to also help communities get together and meet the expectations that we have, right? So in terms of being able to do this certification process, for instance, or even just starting with what are common terminologies or data formats that our community should use if none currently exist. So this is going to be, in some sense, a supported platform, and currently it is supported through funding from Netherlands and Germany, and I think France has also joined as well. So a number of the European countries are considering how to position or to support this initiative and create at least pan-European. And at the same time, in the NIH Data Commons, this is also our goal, is to make sure that the United States and perhaps other countries are also represented in this way and can participate in the development of standards and processes and education for fair and for fair metrics and fair assessments and so on. Okay, so our next steps are really and as embodied through the NIH Data Commons and with Elixir and many others, is to develop these metrics in an open way. So this is just getting off the ground. You should see more announcements about this in the month of February, where we hope to have online forums or teleconference calls. As well, you can always participate through the issue tracker and maintain the pulse of community. But we hope to continue discussing this in a very open way and to hear your thoughts about how these metrics should operate, what is important to you and your community, and to help you create that kind of infrastructure that you need. So we want to develop shared infrastructure to support metric-based fair assessments. You've seen some of it, for instance, in the case of biosharing. We also want, or fair sharing, we also want to see other kinds of resources that can be brought to the table and can be tapped into by different communities. To build applications that create and publish these fair assessments, and I think that we'll see over the next 6 months in the NIH Data Commons. And that will really help us, I think, move this beyond just a theory and ideas, but really into practice, and to build training and support for their implementation and adoption. And finally, again, to test our hypothesis, which is that we think that fairness is going to help in terms of reuse. And I think we need to test that and to measure it. So we will be trying to measure the impact of FAIR and the efforts that we put in, that all of us are putting in to try to improve the quality of our digital resources for consumption by others, and also the tooling that can emerge and the analyses that can emerge from massive availability of all kinds of data, like we saw with Profesh Khatri's work. Okay, so with that, I just want to acknowledge, again, lots and lots of people have been involved in the development of the FAIR principles and ideas around scholarly research. And we've seen lots of people from RDA, Force 11 that have been participating in these discussions, many other groups as well. And from the FAIR metrics, special recognition for Mark Wilkinson, Susanna Sansone, Eric Schultes, Peter Dorn, Luis have all been contributing members to getting us started here, but by no means is this the end. It's really just the beginning. And we hope that the work that we've been doing provides a catalyst for what we hope will be a final set of metrics that we can use across the different digital